Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field to teach you about geological processes. Okay, so we can see here the waves coming in, crashing into the shore. Bit of froth and foam as the wave crashes onto the shore. And we'll get a close-up in a moment so you can actually see the grains being tumbled and washed. The main wave comes and breaks on the shore and then washes back down the slope here. So you can see a bit of a slope built up here. Finest sediment at the top is get washed up the closest, and the coarser fragments stay out a little bit further. But you can see different shorelines being built up. You can see coarser fragments here where the owner actually has tried to build up a bit of a wall to break the waves so that they don't erode further. So the waves, as they come in, they're actually interacting with the bottom of the lake and creating those wave ripples. So those wave ripples are also pushing sediment over top of the ripples, and the coarser fragments fall into the bottom and the finer on top. But as the wave gets closer to shore, then we drop out the coarser segment that's being carried. They're just kind of rolling along, and the finer stuff is being sort of washed along in the longshore drift. So you can see the particles floating in the water. They're getting washed up. It's close to the shore and washing back out with each wave. And if you look at the darker particles, they're floating, but they represent the longshore drift current, which is pushing away from the camera. As you watch the particles closely, they're slowly migrating along the shore away from the camera. Right in here you can see the little ridges. There's the ripple marks on the bottom of the lake here. Water comes in, starts to interact with the sediment on the base. You can actually see some of it floating along, and it creates these ripples, just like the waves on the top of the water. It's creating waves or currents on the bottom of the water, on the top of the sediment that's there, pushing the sediment slowly up towards the shore. It's got ripples along here, all the way up in here. Lovely wave ripples, and they're constantly changing. Over here, you can see the wave ripples. They've got some darker, it's actually fragments of seaweed that are building up in the troughs of the wave ripple. So the grain sizes are being segregated along the wave ripples. They've got coarser fragments and finer fragments. The finer fragments get pushed along, and the coarser ones get caught in the troughs. So what's the engineering link? Whoa, Nelly. So what's the engineering link? Well, if we're trying to protect the shoreline from erosion, one thing we can build is a groin. So here we just use rounded, by the longshore drift current, rounded particles, cobbles. We've built up a barrier that extends out into the water. Now, when the water level was lower, then that would break the waves and prevent the sand from that side eroding across. So we had one on that side, and we've got one over here, one over further, several of them along the shore. So that breaks up the longshore current, and we start to get sand and gravel being caught on that side as it's being washed along. It can't pass through this barrier even under the water, and we also get some of the finer sediment that does make it over the barrier stuck on the other side, as we've got another groin on the other side here. So it works to help prevent shoreline erosion. And we can do the same thing in a larger context, in a harbor, in Lake Ontario or the seaside, and we would just use an engineered barrier to prevent that erosion. But the concept can be illustrated here. So behind me right here, got a barrier island, probably constructed, lots of rock fragments, cobble size and so on. People even made little towers out of them. That's protecting the beach, the waves coming straight in from the Lake Ontario here and eroding the beach. Then further behind me here, right up there, you can see some bigger rocks that have been constructed on the point to protect the point. The point of land is very susceptible to erosion. And then further back, there's a harbor. You can see the lighthouses and some of the sailboat. So we've got a sheet pile wall on the one that you can see there, and then behind it, bigger barrier rocks that have been built up in the deeper part of the water. So all these barriers are protecting the shore, protecting the harbor, protecting the boats from waves, but also for our class, more importantly, protecting the beach from being eroded. And these are all things that we need to engineer and design when we're dealing with the waterfront and the shoreline. Awesome. Take care.